Good evening. This is Dorival Neto, and this is my presentation of the term project for physical science survey lab with Professor Francis Mack. So my topic of choice was how do filters affect colors that we see? So, so throughout the day, we're all exposed to filters, wanting or not. When we drive our cars, we have the windshield. When we look outside a window that has a tint, we have a filter as well. And if you use sunglasses on a daily basis, that's a filter too. So, and they all make a difference on the way we see color, because light will hit an object and the light will hit our retinas, and our retina will transform into electrical signals that will go through our brains and will process that information. And that's the way we see the world. That's the way we see things. And the way that colors work, they all have different absorptions of wavelengths. So that makes a difference on how we perceive and see colors themselves. So let's say that for this lab, I'm using a flashlight or the flashlight of the cell phone, some filters that I found around the house. This is a cap for a business card or something like this. This is the top of a Tupperware, and this is from another color, so that's all I need for this. So the way we perceive light, so if you take a look, if I put this light through this filter here, I think the camera can pick it up. It's kind of purple-ish because that's how the color is traveling through this filter, which is absorbing different wavelengths, and our eyes are catching it in a different way. Our eyes in this example is the camera itself. So that would be a purple one. The red one, very kind of similar. It's a little orange-ish because that's not a very dark red that I have here. And the blue one, that I think it's the one that you can clearly see the difference. It's a little greenish as well. So that makes a lot of difference too, because let's say you're wearing, let's say this was yellow. So anytime I would look at something that was white, it would be very yellowish to me, and I would perceive it in a different way. So it can change your perception on things as well. I also have this medicine bottle, that is a green. So if I put it here, I think that's the best one you can see actually. So it's all green, and let's say you're wearing a glass that has green lenses. So if you look at a red object, that'll make a lot of difference too. It would be like blackish because of how the interaction of all those different things in the environment will make a difference in the end result. So if you have a green one and you look into something red, that would ultimately change the way you see the red object because of the wavelengths that are absorbed by the red object, then reflected to you, and then those wavelengths reflected would be absorbed by the green thing, and it would change everything. So that's how it is. So actually, and this would be my, when it comes to safety or the procedure as well, this is all you need, and a flashlight. So there's nothing to be afraid of. Only don't put the flashlight into your eyes or something and you'll be just fine. So yeah, that makes it for the presentation of my materials, and for my when it comes to the presentation about the topic that I chose. So I'm going to combine this presentation talking about the lab equipment that I chose, which was a stopwatch. So the stopwatch is commonly used to time events. So you could time a number of things, a workout, the time something fell from one place to another, trip from one place to another, and so many other different aspects of what you want to time. So that's why it's used. So in this example is a wristwatch, but whatever. So by pressing a button on the top, you start the clock and it just times itself, and whenever you want to stop, you just press the one here in the bottom and you stop. So when it comes to safety considerations, there's not much to it. It's just a stopwatch. It's a little heavy, so maybe if you hit somebody in the head, they'll get hurt. But other than that, you're just fine. You just put it on your wrist and you use it and you take it anywhere. Normally, stopwatches are the ones that, you know, coaches use and they press the button, but it's the same thing. So another example of how, you know, the data would be taken by this, let's say you're a coach or a scientist and you want to time an event that you're looking into, a player is doing a run, or if you're a scientist, you're looking into how long does, you know, two chemicals take to react with each other, or if you're a physicist, you are looking into how much time does an object has to stop after it's thrown down the hallway. You know, doesn't matter. So that's how you do it. It's a quite relevant item. It's very useful if you're looking into timing things. If you're looking into being quite precise, actually, I think it's a 0.01 second of delay that you have your reaction to press the button. So that's pretty good. And other than that, it's just a regular old stopwatch that you can use to time events that you choose to. So thank you very much. That was my presentation. This is Dorival Neto, with the presentation and the lab equipment item of choice being the stopwatch for physical science survey lab class, for instance, Mac. Thank you.